No, it just like
Yeah,
hot
water.
The hot water extracts the venom
From your
poison. It's like lava water. Yeah.
That I know. How do they keep it hot?
They bought me a new bucket like every 10 minutes.
Bunsen burner.
I could never work them.
Wow.
Oh my God, Sabrina.
Let's get ourselves. Sabrina's got a great story, that's for sure. Now we got to do some great math stuff, though. So let's get ourselves focused. We are ready for number 2, I think.
Shut up, Miranda, for asking the question.
So we are going to start by solving graphically. Did we do this yesterday? Yeah, we did. Okay, so solving graphically, we already did some of this, so this will be easy for us. Let's get our calculators out. We're doing 2A. So we're going to solve graphically. Now, when we did these the other day, they were inequalities, and so we were looking for where it was below or above or whatever. These are just equals. So if you are using the intersection method, you're going to have two things crossing each other, and you're looking for where they cross, right? If you're using the zero method, you are simply looking for where you cross the x-axis. So both of the first ones are set equal to 0, so I think I'm just going to leave them like that and look for my x-intercepts. But I don't care what you do, but let's do it together. Now, word of caution. Remember the first thing we did? We turned that plot on. Some of your calculators will not graph if the plot is on. So you might want to go back in the stat plot and turn it off.
Second y equals.
And then we're going to type in our equation. We talked about how to do this the other day. If you forgot, lean over and ask your neighbor. Where to go what? Y equals. Where'd what go?
No, I know like what to do. I know.
You're such a
I know.
snob.
I'm getting a new one.
What are you going to do?
I know. I'm getting a new one.
It'll work. It'll work. So
I
you
just
have to do that.
So I know it's so much more complicated.
All right, we have our equation in. You also need to adjust your window, guys. Remember our window was set really funky?
What is it now?
Well, let's just do a normal window. So we'll go to zoom 6. That's your standard window.
Like where we had 1999, what do you put there?
You don't have to put anything there. Go to zoom, press 6, and that will fix it for you.
Got error.
No, just go to zoom.
Is there a way to reset?
You still have the error. So when it says syntax, that means that you have pressed the wrong buttons. So if we go to zoom 6, that's going to give you a standard window every time. Okay, you did turn that down. So we need to turn the plot on. So, I am not sure why it affects some calculators and not others. If yours isn't graphing, make sure your plot is turned off. Make sure that you have set your, reset your window, so it's not that weird thing that we had before. You should have gotten a parabola, right? Now, to find the x-intercepts, what's another word for x-intercepts? Zeros. To find the zeros, we go to second calc, pick the 0 option, set your left and right bounds on either side of your point, right? And figure out what it is. Tell me what you got. No, you shouldn't get 0.
Is it -0.5?
Okay, yeah, that sounds about right. Yep, so one of them is -0.5, right? And the other one is 2. Yep. All right, let's try the next one. The next one is not going to be a parabola. So I'm going to go through this one more time. So if you don't know what you're doing, I need you to stop whatever you're doing and listening to me. If you know what you're doing, you can ignore me and then move on. Do this on your own. But we're going to graph this. So I'm going to go to y equals. I'm going to clear out my old equation and type in this one. To type into the 3rd power, use your caret button, which is right under the clear button. Take it to the 3rd power, and then minus x minus 1. So y equals x to the 3rd minus x minus 1. Hit graph.
The one that crosses 0.
And this one looks like your typical cubic curve. It looks something like this, right? So even though we know there are 3 roots, only one of them is real. This is the only one you're going to be able to find with the calculator, okay? So we're going to find that root. So we second calc, pick number 2 option, 0. You gotta set a bound over here, so wherever your cursor is, move it over here somewhere, anywhere over here. Oh, these new cases drive me crazy. Hopefully this hasn't cracked or something bad. My old case was so much better.
Oh, sorry, G. C, Carmel. No, Center Grove. Carmel. Don't say, I swear, don't tell me. No. Or no radio. Nope. How many C's goes in there?
All right, what did we come up with? So we second calc, set our left bound over here, our right bound over here, put it in between, and what did you come up with? 1.32, yep, so x equals 1.32. If this had been one of the inequalities, let's say this had been, oh my gosh. Okay, this video is going to be great to watch. I hope everyone have to watch it. We're going to have a lot of slamming going on. Am I doing this right?
I think so.
Slip that.
I've never used one like that.
I know, I hate it. I'm going to have to ask them for a different
Definitely
case.
has that though.
I'm going to have to get a different one because, oh no, it falls every day.
They're like out there.
And one of these days. Okay, if this had been an inequality, then we would look for where we were above that point. So the answer would be everything from 1.32 to infinity. We're looking at the x values. So if this had been a greater than, it wasn't, but if it were, we would want everything to the right of 1.32. Okay? Okay? All right. All right, now, number 3 says, solve using intersections. So this is the kind that you're gonna put in 2 separate equations for. You're gonna put in 3x squared as one equation and 12x for the other one. You're still gonna go to second calc, but instead of choosing 0, you're gonna choose intersect. And you're still gonna set left and right, but it isn't gonna say left and right, it's gonna say first curve and second curve, but the operation is the same.
It's 3x cubed.
Oh, 3x cubed?
Yeah.
Oh, it is, okay, good. Thank you. Potentially now, we're gonna get 3 points of intersection. I don't know, let's see.
Do y equals 3x to the third and then start another y equals, like y to the equals.
3x cubed and 12x.
Cause it's like you have the variable on both sides, so like and then.
We need to talk about this a little bit.
Got 0, 0.
Did you get kind of a hard thing to interpret, to look at? So, I want you to look at the screen, look at what you've got. Everything seems a little squished up in the middle. So, maybe we should make an adjustment to our window to spread it out. So what kind of adjustment do you think we will make to spread our picture out this way?
Make it less of a range.
Make the X range smaller, right? So instead of going, so go to window, and instead of going from -10 to 10, which is just normal, that's our normal, maybe we go from -4 to 4. Now remember, when you're pressing negative, you gotta use the negative button. So -4 to 4. Now let's press graph. Did that help at all? Well, it certainly helped horizontally. But remember, we're looking for the points of intersection. Does it look like maybe there's gonna be one up here and maybe one down here that I can't see? So if I want to see those points of intersection, what should I do? Go back to window and change my Y's. Now, I made my X's smaller, but my Y's are gonna have to get bigger. I don't care, pick a number, I don't know, what do you wanna use? 30, -30 to 30, let's try that. Wow, good job. Do you see 3 distinct points of intersection? Okay, let's find them, like you know how to find them. So, second calc intersect. And then first curve, second curve. Remember, your first curve is gonna be the curvy one.
Put it to the left.
So the cursor's on the curvy one, set it to the left of the point.
To the left of the point.
Then your linear one, set it to the right of the point and find the point.
Points or just the first?
You know, so I don't care what order you do it in, that's not, I gotta do each one separately though.
The first point of intersection of these lines, one, did you get this? No. Oh, that's a, should we, wait, for the first, does it matter which point of intersection you start with?
Nope,
What?
Okay.
nope, you gotta find each one. Now, the boys are up here, I love it. The boys are up here in the front and they're making conjectures. They are conjecturing, they're kind of guessing that this was the one down here at the bottom. This one was negative, X was -2. What do you think that top one might be? +2. And what's the one in the middle? It looks like it's at 0. I am perfectly okay with you making an educated guess. You gotta be perfectly okay with getting it wrong if it happens to be wrong. But I think this is a very reasonable guess and you are right. You are right. we'll talk in chapter 1 about symmetry. We have symmetry here, so those are gonna match up just like that. All right? Good work. Now, put the calculator away for a minute. Why are you guys talking about that? Okay.
You over there in sixth grade?
Solve by factoring. Now, gang, I want you to notice something. We are going to solve by factoring 2 of the problems that we just graphed. So we're going to get the same answers, but we're going to do it by factoring. All right. Let's see. Who haven't I heard from in a while? Let's see. George, my friend, can you factor this little quadratic equation? You can just tell me. Go ahead. We just got to play around with it, right? Okay, so what do we know is going to be in the front? 2x and x. That's right. So that we don't have a choice there. It's going to be 2x and x. Now we really don't have much of a choice here either, because don't they have to multiply to give you -2? So it's either going to be 1 or 1 and 2. One of them's negative, right? Those are our only choices. So little trick here, you probably know this already, but I can't put the 2 here. The 2 cannot go here, because if I put a 2 with another 2, then I would have to be able to factor out a 2, and I can't factor out a 2. So once I put that 2 there, I knew the other 2 had to be back here. Probably plus and minus so that it works out to be a -3 in the middle. Right? You know how to do this. You've done about 18 million of these in your life. So what's x? X is either -1/2 or x is 2. I want you to look back in your notes at problem number 2a. Is that what we got? Of course it is. Of course it is. That is the answer to the question. All right, now we're going to do the one we just did, the one with the cubes. We're going to solve it by factoring. So I'm going to go ahead and subtract the 12 over. Finley, what do you think we ought to do here? We got to solve this thing by factoring.
I would take out a 3x.
We call it the GCF, right? We always want to start that way. Good work, Finley. So take out a 3x, what do I have left?
It's x squared minus 4, and then you can break that down.
How can I break that down?
3x, x plus 2, x minus 2.
We call this the difference of squares, and the difference of squares is factored that way. So guys, what are our answers? X either equals 0, -2, or 2. That's what we got graphically, right? Way faster to do it by factoring. The problem is not everything factors. So, all right. Number 5, solve by extracting square roots. Good grief. That's the math language for take the square root of both sides. Does that make sense to you, that if you found that problem, you would just square root both sides? Now, caution, I'm going to square root both sides, but I got to remember on one side or the other, and I usually do it on the side without the x, but it doesn't make any difference. On one side or the other, you have to include the plus or minus. When you square root a number, when you literally square root the number, you have got to put in the plus or the minus. The square root of 9 is plus or minus 3. Square root of 25 is plus or minus 5, which means the answer to this problem is plus or minus 5/2. I think we did that one graphically too. Maybe not. I did at some point. That's it. Okay, yep.
So on that, you only do the plus or minus on one side.
Okay, you can do it on both sides, but it's redundant.
Yeah.
Because if you put it on both sides, then you're gonna have positive, positive, negative, negative, which is the same as positive, positive, and then positive, negative, and negative, positive, which also match. So you can do it on both sides, but you're still only gonna have 2 answers. Okay? Now we're gonna solve by completing the square. Well, we talked about this a minute ago, before lunch. We talked about the process of completing the square. All right, so who remembers those steps? This one's easier than the other one we did. Is it Allison? Yeah.
You'll wanna move the 4 over to the other side.
Yep, good. Then what?
Then you wanna divide 10 by 2, and then, square root it.
Square it.
Yeah, square it.
So 25? Okay, so a couple of things about that. When I moved the 4, which is exactly what I want to do, I left that blank space there because the 4 is a bad number and you need to find the good number, so you're gonna figure out what the good number is to add in there. Second of all, this has to be a 1. Now Allison got lucky, it's a 1. But if there had been a 2 here, she would divide everything by 2 before she got started with the process. Okay, what's this? Perfect square, x plus 5. Remember, this is always gonna be that sign, sometimes it's a minus, equal to 29. Now what? Square root both sides. So x plus 5 equals plus or minus root 29. And x equals negative 5 plus or minus root 29. This, if you prefer to put your minus 5 on the end and you wrote root 29 minus 5, that's perfectly okay. We normally put the number first, but there's no law that says that has to be the case. Okay, we remembering how to complete the square? Because now we got a doozy. The process is going to be exactly the same. The difference is, this time, we are gonna have to divide, right? So we're gonna divide everything by 3. And completing a square is not so easy now. So what's our rule? Our rule is we take half of this number. So half of 2/3 is 1/3. And we square it. So the number we are adding to both sides is 1/9. What square is this? X minus 1/3, beautiful. X 1/3, beautiful. Get a common denominator over here. I got 22/9. Square root both sides, so x minus 1/3 equals plus or minus root 22 over 3. And then, since they both have the same denominator, you can either just add that 1/3 over, or you can write it as one fraction, 1 plus or minus root 22 over 3. You can write them separately or together, it doesn't make any difference. If we were doing the quadratic formula, this is the way it would have come out, but when you complete the square, it doesn't have to be one. Got it? Perfect. All right, that's enough for today. Good job. Looks like we're going to do some more graphing next time, so be ready. Have a good weekend. Well, you can't go yet. Have a good weekend. Excuse me, I'm going to turn off the video. It's crashed twice.